We're on page 575, but I don't know what numbers we're doing.
I put 1 through 27. We'll see how far we get done.
1 through 27.
Well, I put 3 through 27.
3 through 27.
So we're skipping 1 and 2?
No, we just had not to.
No, it's, yeah, change my mind. B. Drawing a second number disc after the previously drawn disc was returned. Independent, because you're going to get the same odds both times. Doesn't matter.
Can I write I or D instead of writing out the
Yeah.
number?
C. Rolling a 6 on one of two number cubes and rolling a 7 on the pair. So, I mean, if you roll a die, is what they should say. If you roll a die and you get a 6, does that affect you getting a 7 overall?
Yeah.
Well,
Yeah, it would. wouldn't it?
actually,
You'd have to go one of
Yeah, so you,
it affects, yeah. It doesn't affect the odds, but it does affect what you need. It's so vague.
what is the answer? Like on the, what did they say it is?
Dependent.
Yeah.
It affects what you need, but really the odds don't change.
What affects the odds of getting a 7?
Nothing. Well, your first roll, you can, no matter what you roll on the first die, you can still get a 7.
Yeah.
So
That's
the
true.
odds,
It already said that you got a 6, right?
yeah.
Yeah, but the odds don't change.
But those are the two events. There's two events.
And the odds don't change based on what the first one
If you get a
is, 'cause it
6,
still
does that
wins.
affect you? Alright, just put dependent. We'll move on. Drawing a second numbered disc after the previously drawn disc was not returned.
Depends.
So that was like the one example where I said if the girl, for heads up, 7 up, if a girl comes up here, what's the odds? The next girl will be a girl. It changes the. If you don't return the person, that changes the odds. So it is dependent.
You said we don't have to do two?
No, we're doing 2 also.
They're doing it together.
Yeah. So mutually exclusive means they can happen at the same time. Oh, sorry, cannot, yeah. Cannot happen at the same time. Inclusive means they can happen at the same time. Mutually exclusive means they can't happen at the same time. Inclusive, together, exclusive, apart. All right. So 2A, rolling a 3 or a 5 on a number cube.
Inclusive.
Yeah.
Okay, so they're saying one roll. Can you get a,
No.
it's exclusive. Mutually exclusive.
I don't quite understand.
So you can't get a 3 and a 5 at the same time.
Well, it said or.
So let's talk about in one roll.
Yeah, it means can you get 3
Or.
like two as 2 separate things.
Okay.
Can you buy a hammer and buy a nail at the hardware store at the
Yeah.
same time?
Yeah.
Yes, inclusive.
Okay, what hardware store sells burgers?
It says
It
hammer.
says hammer and nail.
Oh, I thought that's what you said.
Okay, 3.
Wait, what am I thinking?
How much sleep did you get last night, Brady?
This goes back to the Brady's not good at telephone.
No, yeah.
I thought you said hamburger.
Where can I get a hamburger?
Home Depot.
No, Brady. Oh man. C. By being a junior or being a varsity on a varsity basketball team, can you be both of those at the same time?
Yes.
Inclusive.
I could have swore you said hamburger meal.
Hungry.
Yeah.
Getting an A or a B as the final grade in biology.
Mutually exclusive.
Yes. It's exclusive is
5
fine.
minutes on those 2 problems.
Yeah, that's funny. Okay, number 3, an experiment consists of randomly drawing one marble from a bag containing 7 red, 4 blue, 3 orange. Express each probability as a fraction. So this is kind of a review right here. What's the probability that you would draw a red or orange? How many red or oranges are there?
There's
there's
7
10.
red.
There's 7 red, 3 orange, so it's 10.
10. Out of 14,
Yeah.
which reduces to
507.
507.
It's now 14. There's only 4 blue.
7 plus 4 plus 3 is 14.
Oh.
14 marbles.
So
You good, Brady?
No.
10 out of 14.
Yep. Or 5 out of 7. Number 5, what's the probability of getting orange or blue? How many orange are there?
So it's 7 out
That
of 14,
looks-
71.
It's got a laser on it.
It's an LED. Yeah, sure.
How many are there? 7
Out of 14.
out of
71.
14. 1 out of 2. So what they're trying to show here is that getting an orange and getting a blue are exclusive events. So the probability is just you add them together. Okay. If you have mutually exclusive events, the probability of this or that happening, you just add the probabilities together. All right, number 7. Copy and complete the contingency table describing the student. Students in Mr. Jenkins' geometry class then use the table to express each probability of fraction. So go ahead and fill out that table. Just make a 3 by 3 table.
Oh, you just add up and down.
Mm-hmm. I don't know why they didn't just fill out for us, but
Yeah, that's kind of rude. It's not hard.
It was kind of weird.
let's see if I can please. Do you remember?
Well, I think I found the pattern.
synthetic division?
It's not a pattern.
It's an issue, dude.
Like copy a little, don't take up a lot of room, so you might copy the example down, just to remind yourself. That would make, so when you see it on the test, you can see it go, this is how it's done. So, what page it, so this is the problem, this is how this is set up, and whatever you think you want to write. That's, I'm gonna say very likely to be on the test.
is complete.
Alright, number 7, what's the probability that you have a left-handed student or a girl? Okay, it's a little bit trickier because these events are not mutually exclusive, right?
Yeah.
That's a lot of left-handed people. What's wrong with these people? Alright. So, if you think of it like we take all the girls plus the left-handed boys, that would be one way to think about it.
So are you saying we're 5 out of 12? Are you saying 5 out of 12 then?
No. The 12 is just the total of right-handed people. Is that where you get the 12 from? So, how many girls are there?
8.
8. 3 of them. So yeah, you should got an 8 on the girls total. 3 of them are left-handed, so that this is like a inclusive thing. So what you also need to add on to though is the left-handed boys, which there's only 2 of those. Okay, so 8 girls plus 2 left-handed boys. The 3 left-handed girls, that's like a repeat. You don't want to add that number in twice. So there's 8 girls plus 2 left-handed boys makes 10.
So it's 10 out of 17.
10 out of 17. She got 17 in the bottom right corner of your table.
17, wow. You just add all of them together.
Well, yeah, if you add the girls and boys column, that's 9 plus 8. Or if you add the row of left-handed plus right-handed people, that's 5 plus 12. Either way, you get 17 in the bottom right. So there's 10 people that are either girls or left-handed. So it's 10 out of 17. What?
Is that looking at 6?
Oh yeah.
Because wouldn't that only include the 5?
There'd be a 5 out of 17. Okay, number 9, right-handed boy. I don't know why they went easier, but whatever. So what's
7 out of 17.
7 out of 17?
I don't think that reduces.
No, 17 is prime, and 7 is 2. Number 11. Okay, this gets complicated because when it's not a word problem, it actually gets a little more confusing. Okay, probability that A and B happens together. So, and they are independent, so there's no overlap. So, do you guys remember yesterday when I can't remember an example from yesterday. Like, what are the odds of choosing the 5 books in order? The odds of the first book being right were 1 in 5. The odds of the second book being right are 1 in 4. Like multiply the odds together. Yeah, well, I kept going. Third book, fourth book, that thing. So I lost my place. Number 11. Find the probability of A and B if they're independent. So anyway, probability of A and B happening are, you just multiply the probabilities together. This might give us some problems. Yeah.
Wait, so you multiply 0.8 and 0.41 together?
Yeah.
Is that what you do for all of them?
No, they're a little bit different. They're all a little different, unfortunately. It's gonna make it hard.
I got a number.
See, 10 and 12 are ors and 11's and.
0.32A.
Maybe we should do all these. Okay, let's back up and do 10. This odd thing is not working. They keep changing the problems. Okay, on number 10, it says probability of A or B. So that's kind of like, I'm gonna think of a good example. Not like number 3, when it said red or orange. If you just add the probability of getting red plus the probability of getting an orange, that gives you the probability of getting red or orange. So it's an addition problem.
So 0.46?
So yeah, 0.46. It's like 46% chance of that happening. Mutually exclusive means there's no overlap. Like number 7 had some overlap, so you can't just add the 2 things together. But 10 is mutually exclusive, so you do just add the 2 things together. Like it's like drawing red or drawing an orange. They have nothing in common. So anyway,
Well,
kind of hard.
Yeah, there's an equal sign. That's not pretty.
12 is a little different because they're not mutually exclusive. So they're saying there's a 17 overlap. Does anybody want to guess how we're going to do that?
Subtract 17.
You're right. After you add those two together, you take out the .17.
I don't understand.
Wait.
Okay. Yeah, I don't know how to make it easy, honestly. So, on that example from earlier, remember how there was left-handed or girls? And there's some girls that are left-handed, and you don't want to count those girls twice. Like, okay, there were, how many girls were there? There were 8 girls, and there were 5 left-handed people. Okay, but there weren't 13 people that were either girls or left-handed, because there's some overlap here. Some of these girls were left-handed, are included in this 5. So you kind of had to get rid of the overlap. The overlap was 3. I said it differently, but the overlap was 3. So if you just take away the 3 girls, that would be counted twice for being left-handed. That would give you, that's one way of thinking about it. That would give you the correct group. So yeah, you just gotta take out the overlap. The way I said it was, let's just count the girls and then let's count the left-handed boys and just put those together. But when I was counting the left-handed boys, what I was doing was taking out the left-handed girls. I'm not very practiced at teaching this lesson. Alright, anyways, 13. Alright, the A prime thingamajob actually means not A. Okay, on number 13, the probability of not A occurring. So if the probability of A occurring is 81%, what's the probability that A won't occur? 0.19, yes.
Okay.
So that's add up to 1.
So, okay, what is the slash mean? Like divided?
Not at all. It means what's the probability that B happens given that A happened? Are you guys looking at 14?
Yeah.
What's the probability? It's only one they did on this page, but what's the probability of B happening given that A happened?
21.
Let's see. So it says probability of A and B. So the overlap is 0.21.
Is it 74 minus 21?
And it says the probability of A is 0.74.
Oh.
So then it would be,
Point,
20.26, and then you take out the overlap.
Point 26, where do you get that?
yeah.
I subtracted the probability of A from 1.
But that doesn't get you 27.
But it says what would happen if B given that A happens. You need to take out that A happened.
And A and B are dependent. So it depends.
Is it 0.5? Like 0.05?
You know what?
Is it a yes on that?
No, it's not.
I feel like it might be.
Let's circle back. I'll think about that one.
Oh man. That is gonna be a hole on Wikipedia.
Just leave a hole. Okay, 15. Let's see if that goes any better. Probability of A and B, if probability of A is 0.58 and B is 0.32 and A or B is 0.89.
Ooh, add 58, add 58 and 32, and then subtract 89.
Not subtract 89.
No, he's actually right.
Loser.
So you add them together and subtract it.
Yeah.
Why are some of these a lot easier?
Well, they're all a bit different. That's the problem.
So
They're trying to do like one of every
Wait,
case, basically.
0.01.
So I can't just do the odds with
That's
you guys.
nice. That's the chances.
That's a
So you're saying there's a chance.
So, yeah.
What
I
was
hear
it?
ya.
That's the probability that Brady finds a girl.
Just
Like, that's what I said, that.
Well,
You say about it.
not a lot of independent thought going on here.
I think-
What's the
It's not
chances?
a, it's not a hard joke to think of.
That's the chances Matthew finds his own joke.
Let's circle back to that, Brady.
Awkward sign.
Pretty
Yeah,
really-
yeah.
That was like a really big step up from your usual comebacks. They usually no,
Yeah.
no, you,
It is.
and no.
Yeah, but no one laughed. Except Mr. Jordan. Thanks, Mr. Jordan.
I was more laughing at the
Yeah,
awkward
we-
sign.
We were laughing at the patheticness of the joke, not the joke in itself.
Wow.
It's okay, Brady. You'll get there someday.
Better stick with no.
Yeah.
An experiment. An experiment consists of randomly drawing a ball from a box containing 8 yellow, 3 white, and 4 green.
And two.
No. we
No, I'll come back. I gotta look at it for a little bit.
60?
An experiment consists of randomly drawing a ball from a box containing 8. Is that 16?
Well,
Yeah, this
Eight.
is 16.
yellow, followed by
3 white, 4 green, 2 blue.
Yeah.
11 plus 17, right? And that's 17.
That is in fact 17.
And after replacing the ball, so, okay,
Wait,
replacing
what did I
the ball.
say 16 was?
Silence.
Wait, what did I say?
We haven't done 16.
Oh,
Like, read the thing where we added up how many balls.
There's 17 balls. After replacing the ball, drawing a second ball. Express each probability as a fraction. Okay, what's the probability? I'm on 7. I am doing the odds
Yeah,
now. It's a
17.
little more straightforward.
then.
Probability of green, followed by, this will be kind of easy. What's the probability of getting a green?
4 to 17.
And what's the probability of getting a yellow? So, and then the ball is replaced, alright?
So, you
So we're
put it
back to
and
17
it's like
balls. What's the probability of getting a yellow after that?
8. Yeah,
Are we doing 16 or 17?
17.
Oh,
So is it 12?
what are we doing
16 and 17 are the same thing.
What?
They're the same
16?
thing.
Finish that.
No. Well, they're back, yeah, they're the same thing. But you multiply the other direction, but yeah, it was worse the same. Alright.
Why are we multiplying?
Anyway,
So we can do the same thing for 16.
you gotta multiply that together.
32 or 17.
What?
I'm thinking of different,
Oh, right.
Okay, 19 is a little trickier. It's the same as 18. Well, it's not
Do
the
you
same
want
answer,
the
but same idea.
answer in decimal form for the multiplication? Or you want it
No, just leave it. The book just put 32 over, what is it?
It's
Two
like
eighty-nine.
289. I just left that.
It's the same.
Why they make them the same?
They're probably trying to make a point or something.
It's just a book.
Okay, on 19, this one's a little trickier. It doesn't say white followed by blue, it says white and blue. So, in other words, we could draw a white, then a blue, or a blue, then a white. Those are like the two options. So, what we need to do is figure out what the probability of drawing a blue, then a white is, and add that to the probability of what it
So we're
of
not
drawing a white,
replacing
then a
it now.
blue. So, no, it's still replacing. But there's two ways that 19 can happen. You could draw a white, then a blue, or you could draw a blue, then a white. We need to add the two probabilities of those things together.
Well,
So what's the probability of drawing a white, then a blue?
17,
What's the probability of drawing a white?
3 over 17.
and then a blue is 2 over 17.
So 6 over 289.
Yeah.
Okay, that's drawing blue, then white. What's the probability of drawing white, then blue? That's something else that could happen.
2 over 3. or 2 or 17 or 17.
So it's the same thing, kind of like the last, we were talking about 16 and 17, right? It's 6 over 289. But the probability of either of these happening, this or this, is that added together. So, kind of the pattern is, it helps if you understand, because otherwise you might not remember this, but when they use the word and, it's multiply. But when we use the word or, it's added. So what's 6 289s plus 6 out of 289?
12 over 2.
12 out of 289.
This is not
It's a little tricksy, but I've seen worse.
I like those long problems that take up half the page.
What?
Whoa, chill out.
Why would you
Chill
like
out.
those?
Because I understood them.
No.
Okay, what's 21? What's the probability you get exactly one white? So, this is kind of a mess. To get exactly one, we would need to get a white plus something not white, or something not white plus a white. So that's a lot of
How
probability.
does that? Wait.
Um,
No, I don't get it.
So, okay. So we're drawing two balls. So the way we can get exactly one is we could either get a white and not white, or we could get a not white and white.
Okay.
Does everybody follow that?
Yeah.
Okay, what's the probability that we'd get a white?
3 over.
Is it
3
3?
over 17.
3 out of 17. Okay, what's the probability that we would, on the next draw, that we'd get a not white?
14 over 17.
Right. If there's 3 white, then there's 14 not white. Okay, multiply that together. That would give us the probability of getting a white than a not white. What is that? 42? Okay, the other thing that could happen that would still meet the qualifications is drawing a not white, then a white. What's the
You just
probability?
flip them?
Okay, flip it again. So getting a not white and then getting a white is this probability. So it's the same thing again.
Then you add.
Well, equals 84
Yeah.
over.
If you add those two probabilities together, because they're mutually exclusive, blah, 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 you get the total chance.
Okay.
Okay.
Okay. We're cruising.
I don't think any of these reduce. Yeah, it looks like they're all over 289, so we don't have to worry about that.
You know, I'm okay with that.
We stop there.
Yeah, I guess so. We'll stop there.
Yeah.
Oh,
We're stopping here.
It's gonna be 1 through 21.
yeah, that's fine.
Oh no. What?
Mega stick.
Oh, no, 23. Oh, sorry, I thought we were done with the section.
What?
We need to do 23. I thought we were done with
How
that
could
section.
you know that?
He was going to do that anyway.
No, I would never notice this in the man. Okay, 23,
Wait, why are we continuing?
because we weren't
Because
done.
of Nevaeh.
No, because
Are
we
you
finished
kidding
the
me?
Why don't you
section.
just shut
That's
up,
what we
Nevaeh?
did.
She was like, why didn't we finish
Are you
the
kidding
section?
me?
No, I didn't even say that.
Why did you have to do this?
Nevaeh.
It is not hit on that thing. You guys need to chill.
I cannot imagine.
Don't be so hateful there.
Hey,
Pretty, that impression was pretty good.
Okay.
why would you do this to us?
No, no.
All right, we gotta move on. We need at least one white. At least one white. So, okay, we can kind of cheat on this one. Because on our last answer, we got the probability of getting exactly one white. Which there's 2 ways for that to happen. But what else if I want at least one white, what else do I need to include in that?
Getting 2 whites.
To getting 2 whites. So if I figure out the probability of getting 2 whites, then that I just add that to the probability of getting 1 white, which is the last problem. And that will give us the total. Is it too much?
It's 9 over 29.
Okay. We need at least one. So we could draw 1 white, like we did on the last problem, or we could draw 2 whites. Those are the two things that meet the requirements of having at least one. On the last problem, we figured out what the probability of drawing one white was. On this, so now we need to add to that the probability of getting two whites. What's the probability of drawing a white? Was it 3 and 17?
Mhm.
So the probability of getting two whites is 9 and 289. All we have to do is add that probability to what we got on 21.
Oh, the 84.
84 out of 289. Put all the probabilities together, that gives you all the possibilities. So anyway, that's 93 out of 289.
Which is 3%.
No, it doesn't reduce.
Wait, I messed up somewhere there.
Or if it does, the book didn't do it.
Oh no, I messed up.
Alright, we did most of them, so you guys can go.
We're not doing 14 either.
Oh, yeah, I forgot about 13. We'll go look at
Nevaeh.
Oh my god.
She's the reason we have the history test today.
You only
No,
you
I am
you
not.
went to Mr. Odell and were like, hey, can we take a history test?